Tra la la tra la tra la la tra la la tra la tra la la.
Hey there guys, so far we focused on how to calculate molar mass and how to calculate percent composition of a compound. Now when we're doing different chemical problems, other things we're going to be interested in are how many grams, moles, and particles we have of the substance. So we need to be able to convert between these three things. So our focus for this tutorial is understanding how we can convert between mass and moles. And this links back to the activity you did at the very first day of the unit where we counted amounts of rice and beans. In that activity, our word mole was represented by the word passel. And so you guys were able to weigh out how much one passel of either rice or beans weighed. So in chemistry, our word passel is really the word mole. And based on the periodic table, we can figure out how much one mole of a substance weighs. And we call that the molar mass. So when we're doing the conversion between mass and moles, we're going to use that molar mass conversion, where some number of grams of our substance is equal to 1 mole. And that number of grams, remember, is from your periodic table. So what would a problem like this look like? If we come over here, we might be given the problem, how many moles are in 92.2 grams of iron 3 oxide? So this would be the amount I had to start with, and I want to figure out how many moles of that substance that I have. So I can see if I'm looking at my mole map over there, I'm starting at mass, and I'm going to moles, so I should end with the unit moles when I'm done with my calculation. So I want to set it up like a question. So how many moles are equal to 92.2 grams of Fe2O3? So all we're going to do is a dimensional analysis problem. We're just going to track our units. Because I know my conversion is number of grams equal to 1 mole, I can set my units up first. Because I'm starting with grams, that means the grams in my molar mass has to go on the bottom. So my grams of Fe2O3 will go on the bottom, and your molar mass is always equal to 1 mole of that substance. So I'll put 1 mole of Fe2O3 on top. Now all I have to do is figure out what my molar mass is. And just like we learned 2 tutorials ago, we would simply just add the mass of 2 irons to the mass of 3 oxygens to get our total, which I've already done for you, which is 159.687 grams. So we cancel our units, our grams of Fe2O3 cancel, and I'm left with moles of Fe2O3, which is what I'm trying to solve for, so I can do math in my calculator. So I would simply do 92.2 times 1, which gets me 92.2, and then I would divide it by 159.687. And when I do that in my calculator, it's going to kick out a number. How you figure out what to round to will either tell you what to round to, or you can look at how many numbers you started with. Because I started with 3 numbers, I'm just going to put 3 numbers in my answer. So in this case, I would get an answer of 0.577 moles of Fe2O3. And if I want to double check my math to make sure it makes sense, if I look at my molar mass, it is a lot bigger than the mass I'm starting with in my problem, so I should understand that I should have less than a mole of that substance. So I've got 0.577 moles in that pile of 92.2 grams of iron 2 oxide. The other thing we could ask you to do is calculate from moles to grams. So in this case, we'd be going backwards in our mole map. We'd be starting at the mole box and working our way to our mass box. So we're still using that molar mass conversion again. So I'm going to do the exact same setup, except this time I want to know how many grams are equal to 9.45 moles of N2O3. So if I track my units just like I did above, I'm still using my grams to mole conversion. I'll have my 1 mole of N2O3 on the bottom, and I'll put my grams of N2O3 on top. And again, I'll use my molar mass, so the mass of 2 N's and the mass of 3 O's, which if you do in your calculator correctly should get you 76.011 grams of N2O3. So now if I focus on tracking my units, my moles cancel, I'm left with grams of N2O3, which is what I wanted. So in my calculator, I would just do 9.45 times 76.011. And that would get me an answer of 718 grams of N2O3. So you would see I need a whole lot of that substance to get 9.45 moles. And that's it for these one-step conversion problems. If you're going 2 moles, you will always divide by molar mass. If you're going 2 grams, you'll always multiply by molar mass. Good luck, guys.